The ancient Greeks told of how Prometheus stole fire from the gods and brought it to humankind. Today, Prometheus is bringing better observability to Kubernetes operators as a leading open source monitoring framework. In this episode, we'll look at how to set up Prometheus on GKE and use it to instrument your application with custom metrics. This is the Stack Doctor. Last time, we looked at how to use OpenCensus to add custom metrics to our application. Today, we'll do the same with Prometheus. Before we start, a bit of background. Prometheus is an open source systems monitoring and alerting toolkit originally built at SoundCloud. It has a very active developer and user community and joined the Cloud Native Computing Foundation in 2016. So, how do you set it up? The fastest and easiest way to actually set up Prometheus in your GKE cluster is to use Helm, which is a package manager for Kubernetes. Once you have Helm installed and configured, you can install Prometheus in your cluster simply by running the helm install stable/prometheus command. The install will create multiple components: the Prometheus server itself, an exporter running on every node to capture node statistics, alert manager to send email notifications, and the push gateway to accept metrics to be pushed to Prometheus. We'll primarily interact with the server. Let's validate the installation by port forwarding the server pod to our local host. This allows us to access the Prometheus UI and graph metrics to confirm that data collection and persistence are working. Now that Prometheus is installed, we are ready to start adding metric instrumentation to our application. But first, let's quickly review the kinds of metrics that Prometheus supports. A counter is a cumulative metric that represents a single increasing value that can only increase or be reset to 0 and restart. For example, you can use a counter to represent the number of requests served, tasks completed, or errors. A gauge is a metric that represents a single numerical value that can arbitrarily go up and down. Gauges are typically used for measured values like temperatures or current memory usage, but also counts like the number of concurrent requests. A histogram samples observations and counts them in configurable buckets. It also provides a sum of all observed values. Histograms are most often used to measure the distributions of things like request durations or response sizes. Finally, a summary samples observations and provides a total count and a sum of all observed values. It also calculates configurable quantiles over a sliding time window. Summaries are usually used for values where the total value is important, like payload sizes. Now that we know what kind of metrics we can expose in our application, it's important to understand how Prometheus itself works. It's a basic pull model. Our application needs to expose a dedicated endpoint where the metrics will be available, and we'll need to tell Prometheus where that endpoint is and how frequently to scrape it for metrics. Let's do both of those now. First, let's instrument our application. We'll create a simple Go application and expose a gauge metric in it. Here's the code. You can find a link to the repo in the video description. The first step is to define the metric itself as a gauge and provide its name and a description. Next, we create a function that will set the value of our metric. In our example, we're just generating a random value so that we know it'll change every time. Now we can run our application. When we access the metrics endpoint, we can see that our custom metric is generated and shown here. Now our application is instrumented with a custom metric, which is being exported to Prometheus. We need to tell Prometheus where to find this information. We'll do that by adding some annotations in the deployment spec in our application before we deploy to Kubernetes. We'll enable scraping and define the port and endpoint where the metrics are available. Our last step is to set up Stackdriver integration to have this metric be ingested into Stackdriver. We'll install the Stackdriver collector in our cluster, which will patch the Prometheus server deployment. Now when we go to Metrics Explorer, we can see our random value metric there. I hope that you've seen how Prometheus is a fantastic way to add custom metric instrumentation to your application and have those metrics be ingested in Stackdriver. Thank you for joining me today, and come back next time when we explore options for managing monitoring and logging costs. That's it for this episode. This is the Stack Doctor. Stay healthy out there.